Alright, so welcome to CS251. In this video, I'm going to go over the content structure of the class and how we're going to explore data structures together. So I call this kind of approach to this class a client-first approach. So what that means is that early on in the semester, we are going to start with understanding abstractions using the C++ collection classes associated with each of those abstractions. So what does that mean? We're going to talk about this terminology a lot, so if some of this terminology is new to you, no worries. But what it means is we're going to go through and use the standard implementations of stacks and queues and maps and hash tables in C++. So we're going to solve a bunch of problems with these standard implementations. That's going to make it so that we're familiar with all of these abstractions. And then moving on from there, we're going to start building those classes, practice object-oriented programming, which we won't spend much time reviewing, but through building the data structures classes, we'll get to see a lot of that. And then at the end of the semester, we're going to go through and implement all of those big data structures that should be new to you. We will start off the semester reviewing C++. So all of you are coming, from kind of different backgrounds, and so some of you maybe have never used C++ before, and some of you maybe have. The first project that you're going to be working on is basically going to get you all up to speed in C++. So we'll review some things, particularly some maybe more advanced things that you haven't seen even if you have taken a data or have used C++ before. And then we're going to end with 2 weeks that are the last 2 weeks of class. So the second to last one is Thanksgiving, and the very last one is like the week before finals week. Kind of looking at, what is next? What do we use all of this information on data structures for? And that will be really fun. There'll be lots of kind of applications and real world applications for it. Some of this is because I want to make sure that there's enough time for you to use everything you learned on some of the last projects that you're going to be working on. And some of it is just like the way that the schedule works itself out for. Okay. So is this class right for you? So this class is coming in with 2 prereqs and a co-req. So, there's a missing word there. So you should have a C or better in CS141, C or better in CS151. Those are the prereqs. For any of you coming in or transferring in, 141 is like the second programming class at UIC. You should have basically been introduced to recursion, to pointers, and to some of those like slightly more intermediate advanced programming topics that usually aren't covered in any kind of real serious you don't usually spend a lot of time on that on the first introduction to programming class. So it's kind of like intermediate an intermediate level of programming, so 1 or 2 classes coming into here. CS151 is the theory class where you learn set theory. And then the co-req for this class is 211, which is generally like a coding practice class, and a lot of the topics overlap with this class. So in that class you'll be doing a lot more with data structures and practicing a lot more of the same topics, which is great. So what does this mean? So you should have some experience with or can pick up quickly C++. So either you programmed a little bit in it, or you've programmed a lot in something else, and so transitioning to another language is just a matter of learning the different quirks that are different, and then the syntax. You should have been exposed to object-oriented programming or have some experience with it. It's typically covered in like an intermediate class. And then you should have lots of experience coding, testing and debugging. And one good way to know if this class is right for you is to feel out Project 1. So if Project 1 goes okay for you, then you're good. Okay, so why do so many people find the data structures class challenging? Well, not unlike many other CS classes, or particularly programming heavy CS classes, we are combining a lot of different things at once. So C++, it's not an easy language. It's a challenging language. It has everything in it that you could possibly ever want and that you probably don't want. And so it's not for the faint of heart. I don't know if that's a saying, but I just used it. You have just technology, right? So you're using a computer, you're using all of these different systems. There's always challenges with that. You have lots of problem solving and lots of logic in this class, and it's the reason I love it so much. It's so interesting. There's often so many different ways to solve the same problem. Oftentimes I see students doing things and I'm like, oh, that was a good idea. That was cool. You know, it's really cool in that way. And then we have tools. So we're going to use Valgrind, which is probably the first for many of you, which helps with memory management. And then you just have like IDEs, submissions, testing, all that kind of stuff all in one, which is what Memer is for us. So many, many complex topics at once. C++, classes, once you start doing all of this class writing, you have constructors, you have new keywords that you've never used before, new meaning new to you, but also the new keyword, the keyword this. You have all of these symbols that look really fun, but are actually doing like really powerful things, and some of them do lots of powerful things all at once. It's a lot. And so, if anything, it's a class where maybe you have formed slightly bad habits in the past, particularly bad coding habits. Maybe you have formed bad habits that you're like trying to avoid something, like, oh yeah, I know that's really complicated, but I haven't quite figured that out yet, and you just kind of play around with it until it works. That's not going to work in this class. So all of those habits get exposed, all of those bad habits get brought to the forefront, and so you have to stop and you have to start figuring it out. And I think that's why people find it challenging. So, you know, if you've used pointers a bunch and you're just like, yeah, that works, I'm just going to try this. If it doesn't crash, it's probably right. That won't work anymore. If you've never diagrammed out your memory or diagrammed out something that you're building and just kind of like guessed until it worked and passed the test cases, that definitely won't work anymore. So you kind of have to start being a little bit more critical and more deliberate with some of these things. So the course outcomes are laid out on the course Blackboard page. And I won't read through them, but this is what they are. One of the things that's nice about forcing us to go on Blackboard is that now all the course outcomes are linked to our weekly objectives. So when you go into any of the weekly content, you can see how they come back to meet these course outcomes. But a big part about this course is data structure design and implementation. And a big part of that is runtime efficiency. So you'll see that coming up all the time. And so there's this nice balance in this class of lots of really cool programming, but also lots of really cool analysis that you have to do in order to make the cool programs. So if you're nervous about this course, which I know many of you are, and many of you have reached out to me about it, these are my tips for how to be successful in this class, and really any class. The first thing is to work independently as much as possible. So the best way to understand this material is to figure out all the different details yourself. Now, with that being said, there's also a balance to that. So it doesn't do anyone good to spend 10 hours looking for a bug because you're stubborn and you want to find it and you don't want anyone else to find it. So it's also important to know when and how to ask for help in the class. So finding this balance of struggling and struggling enough that you've learned a lot and you've gotten a lot out of it, and maybe in the cases where it doesn't, you don't figure it out soon enough, you have left time to check in with someone and be like, okay, what's my problem here, and explain the situation and explain everything you've tried. Writing small amounts of code and testing that code often. One of the things we see a lot of students coming in is getting really excited, starting a project, having the whole code written, and then running it, and there's literally thousands of errors. The test cases are set up to test your code incrementally. On the first project, the first step is getting all the data loaded in, and there's a test case to check if you did that correctly. So instead of writing all the code and never running it, you have this natural way of running it, testing it on your own, printing a bunch of stuff out, comparing with the specs, and then testing officially with the test cases. You're going to have to, and I mentioned this already, you're going to have to visualize the stuff that you're doing in this class. So there's no way around it. If you don't have diagrams for some of the codes that we're writing, it would be literally impossible for anyone to believe that it would work or that you wrote it. So you should always have notes next to you. You should always have lots of scratch paper because it's inherent in the design. Memory is a huge part of this class. Whether or not you've used C++ before, doing data structure design, you are controlling the memory. It's like the nature of it, right? So if you don't know what you're doing with the memory, there's no way the computer is. And so you are 100% responsible for it now. So all of that pointer stuff has to be figured out. Definitely work on managing your time, and that's going to be particularly important for this semester being online. You have 2 weeks to work on your projects. You need to start them early so that you leave time for all of the things that you run into along the way. It's just part of the nature of coding. Anyone who codes last minute has had very stressful moments in their life. Believe in yourself. So I don't believe this course is some gatekeeper into the CS discipline. That's not what it's for, and it's not even cool. Each of you are here because you want to be, and we want you to be, and it's a really, really, really cool topic. It is by far my favorite topic, and the thing that got me hooked. I was like, when I took this class, I was like, oh, this is cool. I really like this, and that's all the course is. It's not anything else, and each and every one of you can do it as long as you develop the skills necessary to be able to do it. You have the grit and the perseverance, and that's the same for anything that you need to do. And then you have the kind of time management and project management skills. Starting early, leaving time, checking in, asking the right questions. You can do literally anything if you can do that. Lastly, enjoy. Again, we are all so lucky to have the space and time to do this. I really truly believe that I can't believe that I get to spend the next semester exploring this material again and again and again. It's just awesome. So don't stress out about it. Enjoy it as much as you can. And those are my tips. And like I said, I'm on your team. The whole teaching staff is on your team. All of us are kind of in this pandemic semester together, and wish you the best of luck. It's going to be really fun, and I think you'll all really enjoy it. Please be positive and keep bringing each other up. I know that's what I'll be doing, and I think the best thing about coding is that it's an excellent distraction. So your computer and your code is always there for you to come back to. So if you're having a tough time or things aren't going well, it is a really, really nice, very, very stimulating distraction, and that's something that's worth something. All right, so that's it for this video. Thank you all so much.